Okay, so we're going to keep working on lesson 1 here of chapter 3, but we're on page 138, so question 8. And for each diagram, we're going to draw a net and calculate the surface area. So where do you start when you're drawing your net? The base, or the top is fine, doesn't really matter. But typically, because the top and the bottom are in this case, the bases. So start with the base. Is it a square, rectangle, triangle, circle, parallelogram? What is it? Ah! Rectangle. Why is it a rectangle? Because the two lengths and the widths are. Go get the pencil, man. Oh, jeez. Mustafa, catch. Okay, so draw your rectangular base. I'm going to put it over here. So 10 and 8. Now you need to draw the sides, okay? So what goes on this 8 here? If imagine this side folding down, you would have, so you'd have 6 like this, and this is also 8. So 8, and this is 6. And this is 10. So you'd have the same thing on the other side when this one folds down, right? Because it would be symmetric. So 6 and 8. So that's like the sides coming down on the base. Now, what about the front and the back? So imagine the front folding down and the back folding down. Would it also be 6? 10 on one side, but 6 as it folds down, right? Yeah, so this would be 6. So we have the sides folded down, we have the front and back folded down, but the top, in order for the top to get there, it would have to be attached to either one of the sides or the front or the back. So it can go anywhere. The top can go anywhere. So I would just put it on wherever you have space. So I'll put the top, and the top will be the same as the base. So 8, 10, 8. So this is the top. Now personally, I never draw nets. That's my personal choice. Because I'll show you in a second. If you have a very tough time visualizing stuff, I have these shapes. You could put it on your desk and use it. Okay? Like, here, let me show you something. It'll be like a little momentary moment of fun. You guys ever play this game? It's pretty much the coolest game ever. And I love the sound effects. Uh-oh. This is going on my YouTube video. So this game here is all about 3D visualization. And like you're going to just play this game, have some fun. And you don't even realize you're doing math. That's the coolest part. So yeah. I have played this game many a times. I'm glitching. Whenever I'm like this, I just play around till I get it. And then I'll just commit suicide. Okay, so that's 3D visualization. Okay? Just like Slope Dude hanging off the cliff, yeah. So if you struggle with 3D visualization, then I can give you like the prop here, like in my desk. Or like the Kleenex box, for example. Like this is just the Kleenex box. Look, you got the front, the back, the two sides, and the top and the bottom. Okay? So how would I do this question? I would not draw the net, but it's definitely a strategy that you can use if you want, especially if you're good at drawing. And then I would, like, to be honest, I would go like front, back. The front, back are here, so those are 10 times 6. You guys know length times width, right? And then I would times it by 2 because there's two of them. There's two 10 by 6 rectangles. Then I would do the sides. The sides are over here on the side. 6 times 8, and there's two of them. There's two 6 by 8 rectangles. And then the top and the bottom. And the top and the bottom are 10 by 8, and there's two of them. So we calculate these areas. They're just length by width, and then we times by 2. And if you have the rectangular prism notes, just like this, when you get it on your test, you just go to this page and you just copy the strategy. Okay, that's the whole point of having these open book tests. 48 times 2, 96, and this is 160. And what do we use for the units here? Do we use square units or linear units or cube units? What do we use? Square units. So these are all centimeters square, centimeter square, centimeter square. And we add all these up for the total surface area. So adding them all up, 280, 380, 376. Didn't even need to use a calculator. All right, so let's take a look at the next shape. What's the next shape? What's the next shape? I have a family member in the hospital, young man. I'm just double checking it throughout the day. Okay, this shape here. What's it called? Triangular prism. Good. Because the triangles are the bases, the height is perpendicular, and the sides are all lateral perpendicular to the parallel faces. Okay? So, when we go to do the surface area of this shape, what do you think we should do? The top, the bottom. Good. I'm going to put the T like that. Are the top and the bottom the same? So if we figured out the area of one of those triangles, all we would have to do is times by 2. Hey, Peter. Yeah. So all you guys got to do, find the area of a triangle. Okay, so what's the area of the triangle? Area of a triangle would be base times height divided by 2. You're writing, right, Mustafa? You're writing, right? And pull your hood back. So what's the base? Is it 3, 5, or 4? How do you know it's 3? Because it's perpendicular to the height. So 3 is the base, and 4 is the height. Divide by 2. 12 divided by 2 is 6 inches squared. Then we'll times by 2 because there's 2 of them. So 12 inches squared for the triangles. Mustafa, come on, young man. Focus your energy positively. If you can't, then you got to go. Okay, let's take a look at the sides. Are all the sides the same? No. Because they all have different sides from this triangle. But all the heights of the rectangles are the same, right? So for length times width of these rectangles, all of them will use 8. They all use 8. So you have an 8 times 3. What else do you have? 8 times 4. And what else? and 8 times 5. Get all these, 24 square inch, 32 square inch, and 40 square inch. What are we going to do with all these? Add them up. Also add the 12. And you'll have the total surface area of this shape. So for surface area, often when you go to look at the back, these formulas, sometimes they're kind of crazy. Okay, so what I would recommend is that you just do the individual faces by themselves and then just add it all up. So looking at this, 36, 68, is it 108? All right, so 108 square inches. So what do we use square units for in real life? Look down at the floor. Say we wanted to put hardwood flooring on this floor. Like you're building your home and you want to put some hardwood floor down. What would you do? Buy as much as you can, just go spend all your budget on the floor? You'd measure. What would you measure? What would you do? You take out your tape measure. You go there to there, get the length. You'd go from here to here, get the width, and what would you do? Times them up. Get an answer. And then what you do, you'd probably go to the store and buy more than what you calculated. Why? In case you mess up. Because you're slicing off ends, especially for corners, or maybe the closet. You got to get into the door and the closet. You're going to make cuts on the saw, and then you're going to screw up maybe. You got to have extra lying around. What else do you use when you're building a home for area? What if you got to paint the wall? You just paint? What if you go to the store, pick up a can, start painting, and run out? Go back to the store, and it's another trip. It's a waste of time, waste of gas. What if you buy 3 cans and you only use a half a can and you wasted your money? So what I'm saying is basically you just do a couple quick measurements times the 2. It's always typically going to be rectangles in real life. Get an overage. You'd have to go to a guy and be like, this is how much square feet I need. He would tell you how many paint buckets you need, and you're off to the races. So like this one. Do I care about this one? Why? Why don't I care? Because I don't like trapezoids. I don't have it on my formula sheet, so I likely won't test you on it. Okay, what about these crazy ones that are irregular? How to do these ones? Oh my gosh. I care about these ones. You got to problem solve, right? I hear her saying something. Irregular shapes, you're going to problem solve. And I can't tell you what to do. You have to think about this yourself. But you got to make shapes you know. Okay, make shapes you know. What are your usual suspects? The rectangle, the triangle. That's what you want to make. So Savannah just drew a line like this. Is that the only option? You could go straight down too, right, from the corner there? I think that's good though, because then it chops it quite nicely. Anyways, the book shows you a solution. What does the book do here? They break it into smaller problems. Here's area 1. And look how organized they are. Here's area 2. And if you stay organized like this, when you go to write your final answer, you can go back to it and look. Because like what happens, it's area 7. It's been 8 minutes since you did area 1. Maybe you forgot. You know how sometimes you're doing one thing and then you forget what you were doing 2 minutes ago? Well, if you stay organized like this, you're going to have a much better chance. Okay? So let's try our best and let's do this. For number 9 here. This is a kind of a weird shape, right? Now, are you going to ever have this in real life? Probably not. Right? So, but here we are in math class trying our best to please my teacher and get a good mark so I can pass high school, maybe get to NAID or get a diploma, get a job, right? So that's why you're motivated. Not because you're probably going to do this in real life. This is one of the toughest ones, surface area, that like in real life applications you basically just need a very fundamental understanding of area, length times width for rectangles. That's basically it. But here we go. And remember, you only care about stuff that's on the surface. So like this shape down at the bottom, you would actually just omit that part. You don't need that part because it's not on the surface. Okay? So let's work on this. Let's call area 1 right here, the top. Okay? What shape is that? A square. It has the same formula as a rectangle. 0.5 times 0.5. All right, and if we stay organized, we will have much success. 0.5 times 0.5, I'm getting 0.25. And I don't really care about the units right now. Like, if you skip the units right now, I don't care. But for the final answer, put in your units. Okay, now let's move on. Area 2. Okay, area 2. Marlon, wake up! Language. Marlon's snoozing. I had to wake him up. All right, so area 2. How about we do these rectangles on the side here? So those rectangles on that like tower, I'll call it, are they all the same? How do you know they're all the same? Yeah, the numbers on top don't change. Yeah, it's a square base. If it was a rectangle's base up here, would these 4 rectangles be the same? No. 2 of them would be the same, and another 2 would be the same. So once we get the area of area 2, what can we times it by? There's 4 of them, right? So all we gotta do is times by 4. So what's the area of area 2? Length times width would be? Yell it out. No. 2 times, I'm hearing that. 2 times 0.5. That's 1. And then we'll times it by 4 because there's 4 of them to get 4. Now we're done with that shape. Okay, now we can focus on the bottom shape. Okay, so this is a rectangular prism. Sometimes it helps to draw in these dimensions. Okay. Do you remember what we did on the page before? It was like top, bottom, front, back, sides. You remember that? Well, let's just keep working with the way the book does it. Area 3. What's the measurement of area 3? 1.5 times 1. You see it? 1.5 times 1, you're going to get the area of this shape on the side. And then she says times it by 2 because there are 2 just like that. Right over here, area 3 over here as well. Okay? So then you get 3. So now the sides are taken care of. And it's like a little mental check. Got the sides. Let's do the front and the back. Okay, so the front, we'll call this area 4. This is the front. Area 4. Area 4. Okay, so area 4. The measurements for area 4 are, is it the same? It's also 1.5 times 1. So I guess we could have times by 4 earlier, but whatever. And we'll times this by 2 because the back is the same. So this is 3. So we got the front and the back. We got the sides. What else do we need? What else do we need? The bottom and the top. The top's really weird. There's like this part that has to be omitted. So let's just do the bottom. Yeah, exactly, but let's just get to that last. Let's do the easy one. A5 would just be 1.5 times 1.5. I think that's like 2.25. Yep. Okay, now for the weird one. For the weird one, what we need is this outside area. And it goes behind as well. So how are we going to cover that? Subtract the big from the small. So what's the big rectangle? It's the same as the bottom, 1.5 times 1.5. That's just 2.25. We already know that. And then we got to get rid of this part that we're calling it omit. So what's the dimensions of that? Same as A1. Right? 0.25. So let's subtract off 0.25. And you just get 2, right? Now what do we do with all these numbers? Add them together. Okay, so 4 and 3 makes 7, and 2 makes 9, 11.25, and I got 11.5 total. So put a big box around your final answer, and life is good. How'd that go? That's good. All right. Now we got a weird one at the bottom. Is there more? How much more of this do we got? Who has a question? Did you get a different answer than me, Kenny? Yeah, you can go use the washroom. Okay, I think we'll do one more. Let's do this crazy one together. Do you guys still need these notes? No? Alright, let's do one more together because it's kind of crazy. Let's do this one together. And then I'll let you guys have some work time. Okay, let's start over here on this side. That looks easy. A1. How do I get A1? Mustafa, you okay? 20 times 15. Just length times width. I got 300. Is there another A1 somewhere on this shape? On the other side. So let's times this by 2. And we got 600. So A1's covered. Now I feel like doing these ones on top because it's easy. What's the dimensions of that little rectangle on top? 5 and 15. Times those together. 5 and 15 makes 75. Is there 2 of them? So times by 2. 150. All right. Now where should we go? Do we have to problem solve now or should we do the bottom? Do the bottom, okay. Bottom. What did I just spell there? Bool. Okay. Let's just call the bottom A3. We have, what'd you say? Oh, somebody knows what she's doing. 30 times 15. You just look at it? Yeah, wait till the test comes. People be like, what do I do? Okay. Is there 2 of the bottoms? No. Kendo! Oh, Dream World. Because he's snoozing. No, 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 no. 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 Okay, what about this shape here? Let's call this A4. Do you see that one? What are the dimensions of A4? Now we're getting a little bit weird. Now it's getting a little bit weird. Okay, let's focus in on this shape. I'm going to use different color now. How do I get this blue How do I get this blue length? Guys, this is the hard part. How do I get this blue length? 20 minus 5. How do you do that? Good. So 20 is the big height, right? Take away this little height of 5, and you get this height of 15. Good. And do we know this one? It's also 15. Okay, so A4 would be 15 times 15. A4, 15 times 15. And I just heard somebody say times 2 because there's 2 of them. Do you guys agree? All right, so 225 times 2 because there's 2 of them, 450. All right, have we missed any shapes? The top? Are you talking about like this one here? All right. How are we going to get this guy? Magic? Let's change color so you know where I'm pointing to. 20 times 15? Okay, let's see if she's right. Yeah, you have 30 is this long distance, right? And do we know from here to here? Yeah, 5 centimeters. So minus 10. Good. So this is 20. And the distance across is still 15. So the top there, let's call that A5. All right. A5 would be 20 times 15. I don't know why I started using the time symbol instead of the brackets. What do you guys like better, the time symbol or the brackets? Like the brackets? Times better? Yeah. So 20 times 15 is 300. Do I need to times that by 2? No, because there's only one of those shapes. Okay, what am I missing? The front? The front and the back. So if we could figure out the front, then all we would have to do is times it by 2. So how are we going to figure out the front there? Let's do it over here. Mustafa, stay focused, please. So the front, that's in green here. We're going to have to break it down into stuff that we know. I think we should draw rectangles like this. What do you guys think? Okay, so what's this one? 20 is the height. And what's this little width? 5. And there's 2 of those, right? This is like coloring book. You want to times it by 4? The back too? Yeah, we could do that. That's what I thought we were going to do. I thought we were going to find the entire front and then times that by 2. Question. Once this is done, you go. Okay, so these green ones, 20 times 5 times 4, because you want to do it the hard way, because there's 4 in the back. Or there's 2 in the back, 4 altogether. So 20 times 5 times 4 should be 400. So this is front and back. Now let's do, this is the exact same? What's from here to here? 20, and the height is 5. So we could just times this by, not 8. Let's just, we already have it, so 20 times 5 times 2. So that would be 200. Now all we do, guys, is add all these up. Starting at A1. So that's why we stay organized. 600 plus 150 plus 450 plus 450 plus 300 plus 400 plus 200. It's 2550. Now I'll put the units, centimeter square. There's the total surface area. Do you think you guys could do this on a test? Chunk things into rectangles, keep things organized. Don't fall asleep, Marlon, or throw something at you. Marlano. Kendall, snoozing at the desk? Oh, what'd you guys do all night? Where'd you have a big lunch? Didn't even eat this morning. Oh my gosh. Okay, that's it for today.